So let's start with another expression. Here we have a to the power b to the power c to the power d. So we will solve it first using the direct method, and then we will solve it using stack. So we have already learned that exponential has the highest precedence, therefore we have to solve it from right to left basically, right? So here we solve this first. So I will write this as it is, and then I'll say C D, and I will place this to the right of operand 2, where here C is operand 1 and D is operand 2. So this expression has been completely solved. This has been solved right now. So now I have a to the power b to the power cd to the power, right? So now here this becomes operand 1 and this whole thing becomes operand 2. So I'll say here a b c d, I'll write power as it is, and I'll bring this power to the right of operand 2. So here this becomes like this. Now here this becomes operand 1 and this whole thing becomes operand 2. Therefore a b c d to the power to the power to the power, right? So this is our postfix expression for this infix expression. The same thing we can solve it using a stack. So here I will so in stack we have already studied that we need to scan from left to right each and every token, a to the power b to the power c to the power d. Each and every token will be scanned from left to right. The first token is a, right? Nothing in the stack, I will output a. Then I have to the power. So power is exponential. Exponential is basically a operator, therefore I will just push it into the stack and I will write a as it is. B exponential as it is, a b, and then comes exponential, right? And then now that I have exponential and exponential both have the same precedence. Therefore if they have the same precedence, right, then associativity is from right to left. If associativity is from right to left, then I need to push it into the stack. So we have already studied in the previous videos that if the precedence is the same and the associativity is from left to right, we used to pop. But here if the associativity is from right to left, we push it into the stack and AB remains the same, right? Now after B comes C, right? This is not an operator, therefore I will say A, B, C. After C comes exponential. Now I will compare exponential with this operator top of the stack, right? These two have the same precedence, therefore as I've already told, if the incoming operator has the same precedence as that of the operator in the stack and there is right to left associativity, then I push it into the stack. I push this into the stack. So now here I say A, B, C. Then comes D. D is not a operator, therefore I'll say A, B, C, D as it is. Now we have evaluated the whole expression completely. Now the stack contains this, so I will pop this first and then this and then this, right? So I'll write down the whole thing, A, B, C, D. I'll pop this operator, so this is gone, so I'll have only two left. I'll pop this now, right? And I'll have only one in the stack. I'll pop this. Now the stack is empty, and now my postfix expression is this, which is exactly the same as we have got using the direct method. Correct? I hope you have understood this. So the one important thing to note here is that whenever you have the same precedence, whenever the incoming operator has the same precedence as that of the operator in the stack, check out the associativity. If associativity is from left to right, then pop. Here in this example, associativity is from right to left, therefore push the operator into the stack, right? Okay, let's move on to the next expression. So here I have this expression. So we know that we need to solve first by using direct method. I need to solve the parenthesis first, so I will write it as it is. The one important point while solving is that whenever you have parenthesis, write the other sub expression as it is and then solve the parenthesis first, right here. Now I have in this parenthesis I have two operators, exponential and minus. We know that exponential has the greater precedence, right? So we need to solve this first. So this is operand 1, this is operand 2 here. I will still put the parenthesis because after solving this we still need to evaluate or solve this minus here, right? So I'll say here c d to the power minus e, and then I will close the bracket, right? Now I still have the parenthesis and I still need to solve minus, therefore I'll say a plus b star. Now I can I can destroy the parenthesis. I don't need to put the parenthesis because once this is solved, all the operators here are solved. Therefore I'll say c d to the power, right, e minus goes to the right of e, where this is actually operand 1 and this is operand 2, correct? So what are the expression or what are the operators that have been resolved? The operators that have been resolved were exponential and minus. The operators that are yet to be resolved are plus and multiplication, right? Plus and multiplication, very important. Now let us look at the expression. We know that the two operators that are yet to be resolved are plus and multiplication. Therefore we will solve multiplication first and then plus. So to solve multiplication first, what would be the operand 1? B would be the operand 1, because I cannot say a plus b is the operand 1. No, why? Because plus has not yet been resolved. So b is operand 1 and we have already resolved exponential and minus. Therefore this whole thing would be operand 2, right? Operand 1, operand 2 operator. So I'll say a plus b c d to the power e minus star, right? Now here I have put this operator to the right of operand 2. Now we know that only one operator is yet to be resolved. Now this is operand 1 and this whole thing becomes your operand 2, correct? So now to resolve this, I'll say a b c d to the power e minus star plus. This is our postfix expression for infix expression, right? This is our postfix expression for this infix expression. I hope you have got this, right? Now let us see using stack. So we need to get the same answer, right? So I will evaluate each and every token from left to the right, So for example, I will now say a, nothing in the stack because this is not an operator. I will write a here in the output, right? In the output. So this is the stack, right? I just draw like this so that it will be clearer, right? A, nothing in the stack, a. Then comes plus. I'll push plus into the stack because it is an operator. I will write a as it is. Now comes b, plus as it is, a in the output and b, right? Now comes multiplication, right? Multiplication. Now when multiplication comes out, multiplication has higher precedence than that of plus, which means that incoming operator has higher precedence than that of the operator in the stack. Therefore push, right? Push multiplication into the stack. I'll say a b, correct? Now comes parenthesis. Whenever parenthesis comes, just push parenthesis into the stack and write the output as it is, right? Then comes c. C is not an operator, therefore I'll say a b c, right? Then comes exponential. Now the important thing is, we know after parenthesis there is no operator to compare, right? So incoming operator can directly be pushed into the stack after parenthesis, right? After parenthesis, and I'll write a b c as it is, right? Next comes d. D is not an operator, plus star exponential a b c d. Then comes minus. Now minus has less precedence than exponential, so be very careful. We need to compare minus or the incoming operator with the operators after the parenthesis, not before the parenthesis, right? It is less, therefore we know that we have to pop it. So now if I pop it, I will have a b c d exponential, and then minus needs to be pushed into the stack. Where will we push into the stack? After the parenthesis, right? Plus star minus. correct? And then I have E. E is not a operator, therefore plus star minus a b c d to the power e, and then I will close the parenthesis. So the closing parenthesis will be again pushed into the stack. Once I close, I will pop out minus and I will destroy the parenthesis. So here only I will just write minus, and then I will pop out, I will destroy the parenthesis. Now the whole expression has been evaluated. Once the whole expression has been evaluated, we pop out each and every element in the stack, and we know the stack now will contain plus here and multiplication operator at the top of the stack, right? So the top should be popped out first, so I will pop out top here like this, right? And then after this is popped out, then I'll pop out plus. Now the stack is empty here. Now the stack is empty, and the final postfix expression would be this. As you can see, this expression is exactly the same as this expression, which means that our answer is right, which means that the way we have solved using stack is perfect, correct? So I hope you have understood these expressions. In the next video, we will take a little more complex expressions and solve them, so that we can actually finish off or consider all the conditions that might occur while solving infix to postfix expressions. Thank you for watching.